New theme song.
Welcome back to another episode of the SciCast. We are now at episode 10. That is a lot. Today we're going to be talking about graphene, and I am your host, Dr. J.
And I'm Heyman. Brian could not make it today. He had a little problem with the weather.
The entire state of Minnesota had a problem with the weather.
Yeah.
So we will continue on without him.
But it's a great subject today. One of the, I'd like to say, greatest materials in the world.
Could be the greatest material.
Could be. But who knows?
So I heard you have a prop to show us.
Oh, yes, my prop. My prop is,
demonstration.
What does this have to do with our demonstration today?
Regular number 2 pencil.
Mm-hmm. Well, actually, it ain't the 2 pencil that is. It's what's on the tip.
Well, throughout the entire shaft.
Well, I don't know about shafts. So, what does this have to do with us today? A lot. Because graphene comes from graphite.
What you use to circle all those letters on your tests in school.
So, what is graphene?
Oh, Jesus.
Right at this greatest time. Technical difficulties, like always. So, if you like the new soundtrack, we'll be doing it every time. Maybe we'll vote on it. We'll see. So, he's back.
I'm not just unplugging the phone line.
Oh, no, I don't expect you to. So, graphene. What is so important about graphene?
Well, it's lighter, thinner, stronger, faster, awesomer.
Than just about everything. No, let's see. It's...
well, it's made of carbon that's only 1 atom thick.
Yes.
Which is a lot thinner than... Did you talk about the silicone already?
No.
Oh.
I haven't talked about nothing yet.
Okay.
So, okay.
Oh.
I guess the first thing we'll talk about is, what are they using it for?
Right.
So, the first thing is transistors in,
Computer.
of course, well, electronics.
Any electronic device.
So, transistors now are made with silicone. Of course. I hope everyone knows that.
You know, from Silicon Valley.
Yeah.
In California.
So, now, silicone runs around, I'd say, about 10 gigahertz of electricity through it.
Well, that's how fast it runs.
Yeah, 10 gigahertz. Which would seem pretty fast, because, I mean, we got 4 gigahertz processor. Now, graphene, one atom thick. IBM's doing testing with it, and it's 100 gigahertz transistors. It's 10 times faster than silicone.
So it's basically, what could I say? The greatest thing to happen to computers since the computer itself.
Yeah, it is extremely fast. Which makes it a likely candidate to replace silicone. Now, our next...
Well, since we're going to talk about silicon here, we could bring up the fact that, do you think that all those companies out there in Silicon Valley who are basically, their life is based on silicon?
Well, they still have to make certain things with silicon.
Well,
I mean,
if you cut out computer equipment, or let's just say everything that uses silicon, because who?
But they only make the full board graphite.
Why not?
Because they just won't.
Why not? It's cheaper.
Yes, but
stronger, thinner.
And it's more conductive electricity.
Well, you can shield it. Dip it in plastic. I don't know.
Well, no, I believe they would still use silicone for other things, like probably making solar cells.
Boy, he just jumped right into that one. Yeah, solar cells.
Yeah. What else would they make with it? Well, glass is made from silica.
Yeah.
Well, silicone.
Some of it, yeah.
So, I mean, there'd be still plenty of other uses for silicone. It would just not be for electronics as much.
Right.
And then you would have your cheaper ones, since they already have all the stuff for it. I mean, discount prices, you know,
Yeah.
bargain bin stuff.
Bargain bin. I love those.
So, our next topic about graphene, whatever, graphene, is batteries.
Mm-hmm.
Now, who would not like their cell phone to be charged in minutes? Mere minutes, I should say.
When we say charge, we don't mean charge from when it's sitting at 90% and you need to get it back to...
We're talking about close to depleted. Now,
instead of hours, you can wait
Pacific
minutes.
Northwest National Laboratory, in conjunction with private firms, are developing a battery that provides high capacity and quick charging ability. Of course, using graphene.
Right. Graphene.
Graphene. I'm going to screw that up this whole time. I've been screwing it up all week. So, now when it's added to ion lithium batteries... Lithium ion. What's the difference? I just screwed up the name. Who cares?
Okay, I'll forgive your dyslexia.
Okay, so when they add that to the cycling stability and power improves.
Basically, it's a lot better.
Yeah. Basically...
If you had a choice, you'd want the one with the graphene.
Yes, you would. So you could probably charge laptops in mere minutes, cell phones in mere minutes. And I'm using mere minutes because that's what they use to pronounce what they want.
I wonder if car batteries are lithium ion.
No. But I'm sure the electronic ones could be.
Like the Prius?
They could be. So, I mean, plug your car in. What? An hour to charge, maybe? Half an hour? I mean, depends on how big it is. I mean,
yeah.
20 minutes, maybe?
That's real good.
I mean, you could probably just use a solar cells. No.
Well.
Okay. I guess we should move on. Our next great thing about it is bandages.
Oh, this was...
Just wait. Bandages. Why would it be good for bandages?
Because it's antibacterial?
Oh, yeah.
Well, that's a great thing.
So, yeah, it's not antibacterial. Bacteria will not grow on it.
Thus antibacterial.
Well, no, because there's stuff antibacterial that bacteria will grow on.
Like?
I don't know, soap.
No, soap kills bacteria.
Eh,
Well, 99.9%.
Okay, see? So this stuff, it doesn't even grow on.
Do they test it on every bacteria?
I don't know. But human cells are not affected by it.
That's because we're not bacteria, Heyman.
I hope not. Well,
So-
we could be. Think about it. We live on the earth just like bacteria, using every resource there possibly is, then discarding it.
Oh, very existential.
So
yeah.
we're kind of like a virus and bacteria on the earth. So anyway, Troyes, now, so, I mean...
There's a little philosophy for you.
So, I mean, they could probably add this to, like, t-shirts, pants, underwear, anything like that, and have antibacterial clothing.
Well, let's stick with bandages for right now.
Well, I'm just...
I know, but
okay.
we haven't got to the good part because, you know, because not only is it extremely thin, you know, so it's really light and all that.
Well, you could even package food with it.
You could. I didn't even think about that.
Yeah. No, I just read it.
Oh, there it is.
So...
Cheated.
So,
well, yeah, because that would... You could probably... Well, yeah, because we all know plastic is very hit or miss.
yeah.
And you can break plastic pretty easily.
Well,
Yeah,
this is...
With this stuff, it's about to
Oh,
break
this
that.
stuff is dense, too.
Yeah, dense, yeah.
It's so dense that helium can't even pass through.
And helium's tiny.
Yeah, small.
What did I say?
Tiny.
Why you gotta be redundant, tell me?
I always have to be redundant. Ask anyone that knows me. So you want to introduce the next part? This is some of the stuff that is why this stuff's such a great material.
Why?
Well, what's the next part?
paperweights?
Paperweights?
That's just paperweight.
It ain't a
Oh,
paperweight.
paperweight for platinum.
Yeah. So we all know what fuel cells are.
Yeah, making fuel cells.
So now this stuff can make fuel cells more efficient.
And that's, well, not only that, but they're also cheaper, which has always been holding fuel cells back because of their not only bigger, well, not bigger, but big.
So now,
bigger than what we would need.
In fuel cells, they use platinum to produce the electrical charge to break, well, not electrical charge, but it breaks down water into its two components, helium and hydrogen. I mean, hydrogen and oxygen.
Yeah, H2O.
Yeah. H2O, yeah. So that causes the electrical charge. Well, now, since graphene is a conductor of electricity, it conducts easier in water, I'm assuming.
Yeah, it's stronger.
It's stronger
than traditional uses like platinum.
And it gives a solid surface for the platinum to lay across.
They replace because they usually use carbon, right?
Yeah, they use a carbon
just
base.
Just a regular carbon catalyst. Basically a platform in order for all this stuff to happen.
Well, and since it's one atom thick, and a honeycomb structure.
Well, it uses a honeycomb structure in the fuel cells, yeah.
So now
for stability.
Well, that's what graphene automatically makes is a honeycomb.
That's its natural state.
Yep. So, and it handles electricity and heat very well. So, it makes a great building block for fuel cells.
Great shield too, if you wanted to hold the thing too.
Yeah. Yeah. So, I'm guessing, did we actually go through it this fast?
Oh, you keep flipping through these things.
Well, I'm sorry. Do you want to slow down? Do you want to skip back?
Or I think.
I mean, really, how fast were we not supposed to talk about this stuff?
I don't know. We are trying to make them shorter.
We are trying to make it at least 30 minutes long, maybe shorter.
I forgot. I was going to write down the time, but I didn't.
Oh, too bad.
So sad.
So, since we don't got Brian here.
We'll continue with this one, and then I'll come back to see if anything that we haven't brought up yet.
Okay.
So,
who would not like this?
Right. To use, well, I could say instead of traditional LEDs, let's say your HD TV,
or OLEDs.
You know, I could do a really cool thing here.
Yes.
I could actually move the camera for this part here.
We could, huh?
I'm going to show you guys my television here that we're using for my monitor for LED purposes, but you guys already know what it looks like, but I'll do it anyway. See? TV. It uses a traditional LED screen. Let me see if I can get that right back. Okay.